Welcome to my Nat 5 Applications of Maths 2026 Paper 1 walkthrough. In this paper, we're going to look through all 13 questions and have a little go at looking out where the points may have come from. We have our formula sheet, which we will refer to as and when needed. There is a good chance I might just write the formula on without us coming back to look at this sheet. We'll see how we go. There are 13 questions in total on this year's paper. Let's start with question 1. A tyre pressure gauge is shown. Safety regulations require a lorry's tyre pressure must be greater than or equal to 8.2 bar, and Trevor's lorry has a tyre pressure of 112 psi. Mark both pressures on the gauge and to determine if the tyre is safe. So we've got two parts to this. We've got to mark both pressures. So 8.2, we're handily going up into, so 8.2 is here. Right, so this is our 8.2 bar. And our 112 psi, 110, 112, 112 psi. Okay. Now, we're told that the pressure must be greater than or equal to 8.2 bar. So if it was greater than, we'd be looking at it coming this way. It's not. So we do not have a safe tyre. No, the tyre pressure is less than 8.2 bar and not safe. If you wanted to write it as a mathematical format, 8.2 bar and 112 psi, you point to the smaller one, which is 112 psi, and there we go. Okay, remember with these questions, they do want a written answer, so you've got to put some actual words in there. Question 2. Craig is a farmer. Each of Craig's sheep receives 1 dose of vitamins. On Monday, he gave 1/7 of his sheep a dose of vitamins. On Tuesday, he gave a different 2/3 of his sheep a dose of vitamins. Calculate the fraction of Craig's sheep that have not yet had a dose of vitamins. So we have got 1/7 and 2/3 that have had their vitamins. To add our fractions, we have to make them out of the same denominator. 7 times 3 is 21. 7 and 3 are both prime, so there's not going to be any smaller numbers than that. So 7 times 3 is 21. 3 times 1 is 3. 3 times 7 is 21. 7 times 2 is 14. So we have got 14 plus 3 is 17 out of 21 have had. So that is 4 out of 21 still require vitamins. A dose of vitamins. There we go. That was quite simple. Question 3. Helen is saving to buy a puppy. Her monthly net pay is £1,770. Her monthly expenses are £1,420. She plans to save 20% of her remaining money each month. The puppy will cost £1,250. Calculate the minimum number of months it will take her to save this amount. So let's start off with what is her residual income. Her net pay minus her expenses. So 1770 minus 1420, that gets us £350 a month. and she plans to save 20% of her remaining money each month. So she wants 20% of that. 20% is the same as saying 1/5, or you could do 10% and double it. So 10% of 350 is 35. So 20% is going to be double that, which is £70. And that's what she's saving. And how long will it take her to save up 1,250? So I would, as you know, I don't like doing divisions by hand. I would write it that way and cancel it down. And then I'd look at that and go, that's not helpful. So I'm going to have to go for the standard old-fashioned division model. 7 goes into 12 once. I have got 5 left over. 55. 7 goes into 55. Well, 7 sevens are 49. And that leaves me 6 left over. 7 goes into 68 times, which is a 56. And then I've got 4 left, and in decimals here, I don't really care. So I know it goes on. I'm going to put remainder 4 there. Right, so we know it's going to take our 17.8 and a bit months, so the minimum number of months it's going to take her to save that is 18 months. There we go. So we've got a point going to come in from working all this section at the front out. So how much is she saving a month? And another for working out the final answer there. There's a lot of work involved in that for just 2 points. Right, question 4. A company renovates houses before they're rented out. The table shows the tasks that must be completed before the house can be rented out. Complete the diagram to show the tasks and times. The additional diagram in the paper, if you're going to use the additional diagrams or additional sheets at the back, remember to write on the page that it's come from, that's what you're doing. So please say page whatever. In this case, we're told it's page 15. And on page 15, you need to put question 4 so that they know that that's where that came from. If you don't put that, the marker doesn't know to go look at the additional pages. Right, calculate the minimum time taken to complete all tasks. So we're looking for the maximum times here anyway. Okay, so they have handily put in A for us. What needs A? Well, we need 3 things, and we need something that doesn't get anything else until near the end. 2 things here. You can see here we've got the 2 things that are going into 1 and 1 and 1, and then the same 2. So it doesn't matter really what way around we put them. There's nothing that's going in a path that's not joining back up. So the only thing that matters is, has this one here got something coming after it or not? Okay, let's have a wee look. So we have got C needs, D needs, and E needs A before it. F needs D and E before it, so he needs 2 things before it. So F is going to go in here, and F takes 7. D and E are going to go in here, and D is 8 and E is 2. Okay, C will go down here and it needs 3 hours. Right, what needs F? Here we go. F is boiler, is the repair electrics, which is B. And that is 6 hours. What needs B? Repair flooring and repair walls. So H and J. H and J. H is 10 and J is 5. Okay, now we want what needs C, H, and J, which is I. And I takes 24 hours. And then finally, what needs I? That would be there. And that is G. And that is 12 hours. Okay, so we need the minimum time taken to complete all the tasks. Now that doesn't mean we go the fastest bit. We need to look at how long it would take to do every bit of it. So we are actually using our maximum times where more than one thing's happening at once. We have got 4 plus 8 plus 7 plus 6 plus 10 plus 24 plus 12. So 24, 34, 46, 46, 50, 58, 65, 71 hours. Okay, let's have a look at question 5. Ainsley recorded the number of cars that she washed each day at a car wash over a period of 10 days. We're to calculate the median and the upper and lower quartiles. Now, for median, you always put the numbers in numerical order. We've got 7, 9, 10, 14, 17, 18, 21, 26, and 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 31. There we go, we've got all 10. We want the median. The median is going to be halfway. 1, 2, 3, 4, 5. It's going to be halfway between 17 and 18. So that's our Q2. All right, for our lower quartile, we're looking at this section here. Because our median was not one of our numbers, we don't have to ignore anything. So we are here for Q1. And same again on this side. We are here for Q3. That's going to prove important in a minute. Right, we have to draw box plot. Our median is 17.5. Our upper quartile is 26 and our lower quartile is a 10. All right, so we have our lowest number as 7, which is going to be here. Our highest number is 31, which is here. We have 10 as our Q1, so we put that in here. Keep going across. Obviously, you guys, when you're using pen and paper, have a ruler. I'm going up to 26 for the upper quartile. Okay. I could have just used the ruler tool, the straight line tool for that matter. But where's the fun in that? Right, and my Q2 is at 17 and a half, 15, 16, 17 and a half. There we go. There's our box plot. Calculate the interquartile range for the number of cars that she washed. So the interquartile range is Q3 take Q1, which is 26 take 10, which is a nice easy 16. IQR. There we go. Question 6. A warehouse has a ramp at its back door. The dimensions are shown, 180 centimetres high and 12 metres long. Calculate the gradient of the ramp and give your answer as a fraction in its simplest form. Okay, be wary. They've given us meters here and they've given us centimetres here. You want to use one or the other, not both. So I'm going to change 12 metres into 1,200 centimetres and just work in centimetres. So gradient, if you check your formula sheet, you'll see it is vertical height divided by horizontal distance, otherwise known as rise over run. So 180 divided by 1,200, and I can do some simple cancelling down here. And that then gets me an easy one where I can just half it, which is 60. And then divide top and bottom by 3, so I get 3 over 20. Right, there we go. That's it in its simplest form. Next question. Question 7. Gianti sells kitchens. She's paid a basic monthly salary of 1,765 plus commission of 5% on her monthly sales over £40,000. In March, her sales totaled £56,000. Calculate her gross pay in March. So we've got £56,000 in sales, and she's only paid a commission on over 40,000 of them. So we have £16,000, and we want 5% of that. Well, 1% is going to be 160. Remember, all you do is take off the last 2 digits. So 160. So 5% is going to be 5 times that. So 160 times 5, 35, and 3 is 8, so £800. And that's her commission. Okay. So what was her salary? Well, we're told that she's paid the 1,765 plus the commission. So we need to add on the 1,765 and we get a total of £2,565 before tax and insurance, etc. Gross pay. Question 8. David is a pilot. He keeps a record of the distances and times of each flight. The table shows the distances to the nearest 100 miles. And our numbers are going up in our graph in 100 miles. Okay. And the times taken for the flights. And our times going up in hours. We have to draw it out. Okay, this is going to be interesting. Let's try it in blue. Right, so 600 was 1.8, so that is going to be here. 700 is 2.4. 2.4? 2.4. 1,100 is 2.6. 1,800 is 4.2. Okay. 2,000 is 4.4. 2,100 is 5.6. 3,300 is 8.0. Not high enough. There we go. 8.0. And 3,600 is 7.2. Oh, wow, I must have had a tailwind on that one. Okay, now to draw our line of best fit. I am going to use the drawing tool for this one. Okay. Let's get it over here, about here-ish, and draw it up here. Oops. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, I need to move this down slightly. I think if I do that, there we go. That's our line of best fit. Okay, now that we've got our line of best fit, we need to answer part C. David's next flight is expected to last 3.4 hours. Use your line of best fit to estimate the distance of this flight. So we're going to look at where 3.4 hours is, which is here. I'm going to go across, come down, okay, and our line of best fit, my line of best fit, suggests 1,400 miles. Now this is an art form, everybody's answer should be slightly different, there will be a margin of tolerance allowed. Remember that your points have to be evenly split by your line of best fit. So I've got 3 that are on the bottom, 4 that are on the 3 that are on the top. 3 that are on the top, 1 that I've gone through. That's not right. I must have gone through 2 of them. 1, 2, 3, 4, 5, 6. I don't know. Anyway, when you draw it, you'll be able to see your points. I've covered mine up because my line's so thick. I might be able to do something about that. Not letting me. Here we go. Let's make it a thin line. You can go. Yeah, you can see I've gone through 2 points. Okay. Question 9. The volume flow rate of a liquid is calculated using volume of liquid in meters cubed and time in seconds. And using this formula, VFR equals volume over time. Time needs to be in seconds. We've got 54 meters cubed of water and it's got a time of 1.5 minutes. Now that's the same as 90 seconds, so I'm going to write that in straight away. Calculate the VFR and give your answer as a decimal. Our VFR is going to be 54 over 90. Now, 54 is in the 9 times table. That will make making decimals easier. 54 is 6 times 9. 6 divided by 10 is the same as 0.6. And we're looking for meters cubed per second. So I'm going to write that on there as units. Okay, there we go. Emma sells bath salts. The price of the bath salts is directly proportional to its weight. So as one goes up, the other goes up. Emma sells 450 grams of bath salts for £4.32. Calculate the price of 1 kilogram of bath salts. Now, in real life, you'd use a calculator for this, but we can do it. So let's start with, if we know that 450 is £4.32, then 900 is going to be £8.64, and we just need to find 100 and add these together. So how many times does 9 go into 864? Well, 0. 9 goes into 86. 9 nines are 81. 9 goes into 54. 6. We just did that in the last one, didn't we? So 0.96. So we are going to add 96 pence to get our total. 0, carry 1, 6, carry 1. Sorry, 16. That's £9.60 for 1 kilogram. Okay. Question 11. Anne is playing a game which involves rolling a fair dice and flipping a fair coin. The dice has 6 sides, standard numbers 1 through 6. Coin has 2 sides, standard heads and tails. We have 2 possible ways to win the game. If the coin lands on tails and the dice lands on a multiple of 3, so multiples of 3, that's 3 or 6. And the coin landing on heads and the dice landing on an odd number, so that is 1, 3, and 5. Calculate the probability that Anne will win on her next turn and give your answer as a fraction. So the first option there, we have a coin at tails, and that's going to be a half, and dice multiple of 3, so that's 3 and 6, that's 2 out of 6, which is a third. So the chances there, we need an and here. We need both to happen. So if both are happening, we're multiplying. So the probability of 1 as a win is going to be a half times a third, which is a sixth. 2 needs heads, which is also a half, and it needs the dice to be 1, 3, or 5, which is 3 out of 6, which is a half. So the probability of a 2 winning with method 2 is going to be a half times a half, which is a quarter. Okay. So the probability of a win with either method is going to be an or. We can have a sixth or a quarter. And that's where you add them together. We need the denominators to be the same, so let's make it over 12. So a sixth is 2/12 and a quarter is 3/12. So the probability is 5/12 of a win. Okay. Not bad odds, actually. Right, question 12. A garden has been designed in the shape of a square and a quarter circle. Fence will be built around the garden. The fence will have a 1 metre gap as shown. Calculate the total length of the fence. calculate the total length of the fence using pi equals 3.14. Okay, so we know that we've got 10 at the bottom. We're going to have 10 there because it's a square. We're going to have 10 there because it's a radius. And we have a quarter of a circle. So we need our area of a circle. And we need the formula sheet for that. Area of a circle, A equals pi r squared. So that's it here. Let's get back to our question. Right, so we have got A equals pi r squared. Let me just get that. There we go. Right. We have got pi as 3.14 and we've got our 10 squared, which is 100. So we have got the area of a full circle, not the quarter circle, remember. So the area of the full circle is going to be 314. Why am I looking at area? We've been asked for perimeter. And this is where they catch me out with these questions. Right. Okay. It happens to everybody at some point. So we're looking at the perimeter. So if you remember the perimeter of a circle, perimeter is 2 pi r. Okay. And we know that we've got 3.14 for pi. And we know that we've got 10 for r. And we're only wanting a quarter of it. So I'm just going to go the full way here. So this side is going to be 2 times 10, which is 20 pi over 4. And now I can cancel that down, which is the same as 5 pi. 5 times 3.14. So I can do that. 3.14 times 5, I have got 20. 5, which is 7. 15. So 15.7. Okay. And it's just adding up. I have got 15.7 plus 10 plus 10 plus 10 minus 1. Oh, sorry, tell a lie. So that's 10 there, minus 1, which is 9. Okay, so 15.1, 15.7, sorry, plus 10, plus 10, plus 10, plus 9. So I've got my 1, 2, 3, 4 sides and my curved edge. I'm glad we're getting to the end of the paper. I'm starting to lose the ability to speak. Right, so 15.7, 25, 35, 45, 54.7 meters. There we go. I would say by 55, so you've got a bit of extra. Question 13. A company was interested in customer opinions about a soft drink. They carried out a survey. The results are shown in the pie chart. So we've got black is the dislike, grey is the undecided, and white is the like. Following this survey, they changed to a new recipe. They carried out a second survey, and we've got the number of people that answered. Determine if there has been a decrease in the proportion of customers who dislike the soft drink. Use your working to justify your answer. Okay, so the easiest way is to either compare fractions or compare percentages. Let's have a look at what we've got. We're looking at dislike, so I'm only interested in the dislike. So dislike, we have got 60 out of 360, which is 1/6. And dislike here, we have got 70 out of how many? So 280 plus 70 and plus 130 is 480. This is not going to be a nice number. So does 6 go into 480? Yes. 6 goes into 480. 48, 36, 42, 48. So 8 times. Right, does 6 go into 70? Not really. Yeah, probably easier to scale up than to scale down then. Right, okay. So I need to do 80 times this to get it to scale to this. So 6 goes into 480 is 80 times. So I need to do the same on the top. I need 80. Right, so I'm comparing 80 for the old formula and 70 for the new formula. Yes, there has been a decrease in the proportion of customers who dislike the soft drink. Right. Okay, and that's the end of paper 1.